In the next several videos, we are going to turn our attention to probability. So as we start to look at probability, one thing that's going to end up being very important, not only in the realm of probability, but throughout the rest of the statistics that we look at, is something called the rare event rule. What the rare event rule says if under a given assumption, the probability that of a particular event is extremely low, right? So it's that probability is extremely small, and suppose that that event does actually occur, we conclude that the assumptions are probably not correct. So whatever assumptions were made that arrived at that small probability, the likelihood of that event being very small, we would say those assumptions, they're probably not right. We usually define this idea of rare as being less than 0.05. So if something has a probability of less than 5%, then we think of it as being rare. However, it can be specified to a different value. All right, so let's look at some terms that are associated with probabilities. An event is any collection of results or outcomes of a procedure, right? So if we're thinking about rolling a die, we could say the event where you roll a 1, that is, would only consist of the outcome where it's a 1. Or you could talk about the event where you roll an odd number. That would consist of the events where you roll a 1 or a 3 or a 5. Right? So those are events. A simple event is an outcome or event that cannot be broken down into simpler components. Right? So we just mentioned rolling a 1. Rolling a 1 on a standard 6-sided die, that would be a simple event. Rolling an odd number would not be a simple event because we could break that down into rolling a 1 or rolling a 3 or rolling a 5. Rolling a 1 is a simple event, rolling a 3 is a simple event, rolling a 5 is a simple event. So we were able to break it down into these simpler procedures or simpler components. The sample space for a procedure consists of all possible simple events, right? So if we're talking about rolling a standard 6-sided die, the sample space would be we could roll a 1 or a 2 or a 3 or a 4 or 5 or 6. So that would be the sample space there. When we deal with probability, we will use the letter P to denote a probability. We use the letter A, B, C. We use capital letters to denote specific events. So we could say P of A is the probability of the specific event A. So those are some terms associated with probabilities, some just probability basics. We have 3 different types of probability. So one type of probability that we have is a relative frequency approximation. So here you conduct a procedure, you count the number of times that event A occurs, and based on those actual results, you approximate the probability of A. Probability of A is the observed frequency of A divided by the total number of observations. Right, so if I were to roll a die 100 times and I wanted to know what's the probability that I roll a 1, I roll the die 100 times, count the number of times I actually observed a 1, and I can approximate the probability that the die will come up a 1. The second method is classical probability. Here you assume that a procedure has n different simple events and they are all equally likely. In that case, the probability of A is equal to the number of simple events in A divided by the total number of simple events. Now, that total number of simple events, as we saw on the last page, we would call that the number of things in the sample space. The sample space consists of all possible simple events. Right? So with classical probability, I think of that as forward-looking, and relative frequency probability, I think of it as backwards-looking, because we have observed some frequencies based on these actual observed things in the past. This is what we think the probability is. The one other kind of probability that we might have is subjective probability. Here, when classical methods won't work and the situation makes it unreasonable to do a subjective probability, then we can estimate these using knowledge of relevant circumstances. We can estimate the probability of an event. Right? So if you're thinking about a space shuttle launch and you want to know what's the probability of success, well, you're going to estimate that. You can't go through and do a bunch of space shuttle launches and say, based on the observed frequency, here's what I think. And you can't use classical probability there. You don't have all these simple events. And so you do lots of testing in labs and you have good data, but until you actually send that shuttle off, it's unknown. And so you estimate a probability, you have some subjective knowledge where you estimate that. All right, so let's look at an example. So our example is find the probability that the number of calories in one randomly selected case of beef hot dogs is less than 140 calories. So we're going to go back, we're going to look at that hot dog data. So we want to know what's the probability it is less than 140. And so if we're trying to find out what's the probability it's less than 140, what we can do is we can go through here and we can count the total number that are less than 140. So when we go through here, here's 1, 2, 3, 4, 5. So there are 5 cases out of the 20 that have less than 140 calories. So that relative frequency approximation would be 5 out of 20, which is 0.25, or as a percent, 25%. So that would have been using a relative frequency approach. Something else we have here associated with these different methods of different types of probability is the law of large numbers. And so what the law of large numbers says is, as a procedure is repeated again and again, the relative frequency approximation that will tend to approach the classic classical probability. Perfect. Now let's take a look at some other things that are associated with probabilities. So the complement of an event, is denoted with an A with a bar. The complement of an event A, this consists of all outcomes in the sample space in which A does not occur. Right, so if we're talking about rolling a die and we want to know the complement of rolling a 2, that would be all of the possible outcomes where you don't roll a 2. So it would be a 1, 3, 4, 5, or 6 as possible outcomes. With probabilities, we have a variety of properties. Probabilities should always be between 0 and 1. If an event is impossible, it's not going to happen, that probability is 0. If it's certain that it's going to happen, the probability is 1. And you can convert these from numbers to percents. All right, we will talk to you about some more probability stuff next time.